position, and still a big way ahead, as I already showed. Still a lot of this is offline, and we're trying to get that all online. And our team and how we work. On the left you see some numbers. We're now 750 people work for Kubernetes, 50 nationalities, operating in 10 countries. I see the average age and the average tenure. And really our engineering team is responsible for making the magic happen behind each bit. We have a follow-up culture where everybody can make it. And we try to do that using more technologies. Yeah, we try to make everybody feel valued. We try to get everybody's code actually see the light of day. That's what we stand for. Thanks. And now I'll give the word to Alessandro to share a little bit.
Yes. Hey. Thank you, Justin. Thank you, Katawiki. It's a beautiful place. It's amazing. Thank you. Thank you for showing up in big numbers this time. So this is the number 3 meetup of 2022. So the post-corona meetups. So if it's your first time, please reach out to me or to anybody else to get to know the story of this meetup. We've been around for 6 years, so we know how to do this and we love it, right? So my name is Alessandro. I'm an ambassador for the Cloud Native Computing Foundation, right? So it's the foundation that promotes all the cloud native ideas, tools, takes care of a lot of different projects, including Kubernetes, right? So it's just an honorary title. And I'd love to make your experience better. And if you have any suggestion, please come find me or Etienne also. Etienne is also there. He's also co-organizer of the meetup. So why we are here? Because we are humans and humans share stories. We are storytellers. So we are here to listen and to contribute, communicate, to share our stories, not only the 2 amazing talks we have today, but also your story. So please reach out to your fellow cloud native enthusiast and try to be more active in the community. So you can contribute talks, you can contribute, maybe your company wants to sponsor. We just need a space like this. Doesn't need to be so beautiful, but some space will do. Usually this really successful meetup, 50, 60 people. It's pretty much the numbers you get in this country. And one announcement, so the community came together in 2019 for Kubernetes Community Days, right? So which is like a small KubeCon, you can say, but very local, right? So CNCF wants to promote these smaller events where people can actually interact better and more with the local community. So we had a great edition in 2019. We are coming back in 2023 in February, just 2 months before KubeCon. So we are kind of growing and building the hype of the community towards these big events, which is, this one, and of course KubeCon in Amsterdam in April. So reach out to me or go to that link or to community.cncf.io, is all in there. If you want to sponsor, you want us to talk, we open the call for paper on the 1st of August, so we'll be happy to have you speaking there. Especially if you are first-time speakers, if you get rejected from KubeCon or if you think KubeCon is too much for you, this is a very good place to get started with the public speaking. So, and the meetup as well. How to get in touch, to stay in touch. So we are on Slack, so the official CNCF Slack. There's a channel called Netherlands. It's not very active, but if you come, maybe you can make it a bit more active. And if you have any questions about the community or Kubernetes, that's the place. Community.cncf.io. So this is the official community of Amsterdam. Of course, there's nothing there because we are still big on meetup.com. But still, if you want to register there, you're very welcome. You can send us an email. Do you like Discord? I don't know, who likes Discord? Yeah, I can't stand it. But other communities do have this Discord thing, or even worse, Telegram groups. So, but if you suggest it and you get enough traction, please, we can make one. It's no big deal. So this is the old agenda. So, but basically, we're gonna have 2 talks, and then we have 1 lightning talk Who is the Lightning Talk speaker? Maybe he's not
I
here.
think it was someone named Sri, but he won't make it. He couldn't
Ah,
on the page.
all right, so
if there's anyone else,
if you want to share a story, you're a storyteller, come on stage after the talks and you can just plug your presentation somewhere and you can just, you got 5 minutes, you can tell everything. Please don't do like blatant market pitches, but I mean, you feel free to do it. Just you know that we don't receive those very well, right? So we are here to share technical talks and like experiences. So well, if you have something to sell, it's good for you, but please keep it to one-on-one talks. And that's it. So the first talk is from, thank you very much.
I just shared with you.
Yeah, yes. And let's see if the audio.
Okay. Yeah. Thank you for joining. So I'm going to share our experience, how we are monitoring our Kubernetes cluster, and how it was started in the past, and how where actually we end up with the current structure. So this is the agenda. Let's show some delay. Come on. Yeah. So we're going to have a look at the first setup we had when we moved from on-premises to the cloud, the first Kubernetes cluster we had. And then, we'll see what kind of limitations we had in that period of time and why Prometheus alone could not be enough when it comes to the multi-cluster monitoring. And we will have a look at the Prometheus federations. It was the first option on the table to see how it works and how it could solve some of the issues and why it cannot solve all the problems we had. So, and then we're going to have a look at the in details the structure of the Prometheus itself. So why Prometheus alone is not scalable and what kind of issues we have there and why we need something.
For live streaming. Microphone.
Okay, yeah. How's
Yeah, there.
I have it. Good? Oh yeah. Okay. So we're going to have a look at the Prometheus structure, the components we have, and why Prometheus alone, as I said, is not enough when it comes to multi-clustering, and then the Tanos as a solution we have here, how we are dealing with Tanos, how we structure our Kubernetes cluster with Tanos, and what kind of components we have, because it does have a lot of components, and each component takes care of some parts, and at the end, we're going to show you how the current architecture of distributed monitoring cluster looks like here at Katowice. So this was the first setup. So when we moved from on-premise to the first Kubernetes cluster, so we were running 3 instances of the Prometheus. Why 3? Because we have 1 for each available zone, so we have 3 for each region. That's why we were running 3. If one of them, if we have an outage in one available zone, then we still have 2 Prometheus still running. And then we had alert manager, of course, and Grafana on each cluster. So that was the first cluster. So as long as you have only one cluster, it looks fine. But all the problems started when you start adding new clusters to the to your infrastructure. So
if you could speak a little bit louder.
Louder. Okay. Okay. Yeah.
Sorry, we don't have the mic.
Okay. Oh, it doesn't work.
It's for the broadcast.
Okay. So do my best. So we ended up with this structure when we just had the first actually early setup of the monitoring. So we had isolated environment, isolated cluster with isolated monitoring. So very soon we noticed this doesn't work. So if we just keep adding cluster, this structure doesn't work. The first thing we wanted to be able to query against all this cluster from one single place, not something like this to have distributed Graph1 and distributed alert manager. And of course, we wanted to have just one alert manager, which for all clusters to be connected to that one. So that didn't work. The first solution which was on the table was Prometheus federation, which, yeah, let's go for the next slide. I can show you. Yeah, in the federation, as you see, you have one cluster at the top, and it will, federate or scrape all other leaves, all other clusters in the bottom. And this structure could solve the issue which we wanted to have a single place to query all other clusters from just one Grafana connected to this monitoring cluster, and then it scrape all other clusters for us. But the problem was, so if we keep adding new clusters to this structure, so how big this one could become for us. So in some certain points, we cannot scale that anymore. And the scene is, if one of this Prometheus server at the top goes down by any reasons, if we suppose you could get an outage on one region again, something like that, then for sure we will lose some data, and that's not what we want. And two more things we wanted to have. We wanted to start to implement SLO and SLI in order to improve to measure our performance, to see how it looked like. And for this reason, we wanted to store our metrics for a longer period. I don't know, like 6 months, 1 year, something like that. And one of the biggest issue here is, again, that's not doable on this structure to just store your metrics on a Prometheus server for 6 or a year, I can say. And the reason behind that, let's go for the next slide. I can show you why this structure doesn't work. So as you see here, these are in this red square, we have the main Prometheus components. And in the bottom, it's a time series database, which is relying on the local storage. So this is a local storage if you want to, just store metrics for, as I said, for 3 months, 6 months, a year. What if we have a disk failure on this local storage? So then we will lose our data. Of course, we could run 2 instances, but again, storing long-term metrics on a local storage is not a good idea, especially when it comes to the multi-cluster environment. So that was the first issue, and Kubernetes and Prometheus itself says on the storage website that we should treat this structure as a single database node, which means if it's not highly available, that's why we run 2 instances. It's not highly available, and if something goes wrong here, then we're done. And the second issue, let's assume we don't have a problem with local storage. Let's assume everything works fine. And technically, it is of course possible to store your metrics for 6 months via Prometheus. But the problem is, if we want to store our metrics for 6 months on a local storage, that means we need to someday to query those metrics, and that's going to be a pressure on query engine. But as you see in this structure, all the components are running in a single app, or in Kubernetes, I can say in a single pod. So if we want to query something for 6 months, which that time series database is storing for us for 6 months, if we want to query that metric, for sure we will have some serious issue. Most probably we will get killed, out of memory killed on the Prometheus pod. And the problem here is, if something goes wrong for the query engine, it's not only query engine that goes down, the entire server goes down. So that's a serious issue, which we call it the scalability issue. So we wanted to make sure to have a scalable monitoring platform. We should be able to scale, each of this component independent from the other components. That was the next requirement we had when we wanted to consider something like Thanos. And this is Thanos. So the first thing we get is about the global query view. It's when you are able to get all the metrics from different Prometheus server, from different cluster, and store them on a different storage, something like object storage, and you are able to query that object storage. That's what they call it, the global query view. The capability to store your metrics somewhere else, and gather all the metrics somewhere else, and then query it from that place. That is something possible here, and that's a good thing about Thanos. So we are able to store our metrics for unlimited, without any limitations for a year or 2 years in some cases. So as I said, another reason for this need, apart from the SLO SLI we wanted, so you can learn from your mistakes, or you can see the incident response. So that's a good thing about storing metrics for a long term. So it's really neat that if it comes to calculating your error budget for each quarter. So it's really needed. And so Thanos is Prometheus compatible. We are still using Prometheus here. We are still querying with the Prometheus query language. And also Thanos is still using many of the API from Prometheus. So we still have Prometheus, and we still need to have Prometheus. And the last thing is about downsampling and compaction. This is the very cool thing. I will get back to these things in the next slides, but it's very as a summary. So when we store our metrics on an object storage by Thanos, so we do have this capability to compact them, to compress them, and also downsampling is a feature to speed up when you are querying something for 6 months, because 6 months is a very big window. Yeah, and if you scrape your servers, your endpoints via Prometheus in each 50 seconds, for each month it's going to be almost 2,000 samples. So in 6 months it's going to be 1 million samples. So downsampling is really needed in that situation to let us to have a faster query response. So and then let's go for the Thanos components. And so let's see what kind of components we have on each Kubernetes cluster. So the first component is, as you see, these are the 3 Prometheus servers that are running for each cluster. As I said, 3 because we have 3 availability zones. And on each of these Prometheus, Thanos sidecar is running alongside with the Prometheus. Is the sidecar in this pod. And so what does this sidecar do for us? It actually gets all the metric blocks from Prometheus and store that in memory. So, and in the meantime, expose the read-only API for us. So it means in the next components that I'm going to show you, we will be able to query all the metrics which is available on this Prometheus server without directly talk with Prometheus, because one of the goals should be, as much as possible, we shouldn't put a lot of pressure on the Prometheus server, because it's not supposed to handle a lot of pressure when it comes to the multi-cluster environment. So that's a good thing. Get the blocks, store that in memory, expose the read-only API, and then we will be able to query all the metrics on this Prometheus server. And also, it is possible to offload all those metrics on an object storage. It could be an Amazon S3. In our case, it's a Google Cloud storage. So we are able to, all the blocks we have here, to upload them on object storage. So, and that's happening in each 2 hours. So it means we still need to have a persistent volume for Prometheus servers, because after each 2 hours, it will upload that block on object storage. If something happened for one of these Prometheus server, in the worst case scenario, we will lose 2 hours metrics. In the best case scenario, it could be just few seconds. So it's still recommended to make sure we have the persistent volume for this Prometheus server, and then we will upload all the metrics on the object storage. And so the next components, when we are talking about the object storage, so for sure we need another component to read all these metrics from this object storage and give us another read-only API, like exactly what Sidecar is doing, to give us another read-only API, which they call it a store API. It's a kind of a pattern in Thanos that to let us to be able to query all the metrics we have on this object storage. So that's really good. And also, once it reads all these metrics from object storage, let's say we query something to get the last, for 6 months for a specific metric, let's say the number of Nginx requests, it gets all the lives metrics from this one, and also we get all the long-term from the Thanos store. It is also possible to cache that in memory or something like Redis or something again like Memcache. That's doable. One point about this component is stateful. That means we're not able to scale that with Prometheus, with Kubernetes itself. So Because in this component, it does save some of the information for each Prometheus block. So that's why it needs to save some stuff inside in the persistent volume it has. But it's not necessarily sensitive information, so we are able to restart that, because as soon as you restart that, it gets the information again. But there are some solutions to scale this component as well. One solution is we can have a replica for this one. We can say if there is a query request for 1 month, let's just resolve that by pod label, for example, A. If there is a request to get the to query from 1 month up to 6 months, another pod could be responsible to resolve that request for us, and so on. So we can have, we can actually shard the request on different pod here. That's about Thanos store. Let's go for the next component we have. The next component is Thanos query. So as you see here, it is connected to the store and sidecar. As it says, in this component, we are able to query everything which is behind that is the store, which is getting the metrics from object storage, and also these three replica of Prometheus servers. So it is connected to these two data source, and so whenever we want to query something, we can just need to connect ourselves to this querier. So this querier does have something like a Prometheus UI. We can just expose that and directly query something we want. And another good thing it does, exactly like it's happening on Thanos store and Thanos sidecar, this query does also expose a read-only API for us. And that means we will be able to have a hierarchy layer of Thanos querier. So that's a really good thing, because this is only one cluster and we have the same structure on other clusters, and then eventually in the monitoring cluster we will be able to just connect ourselves to this one, and from this component we do have access to all the metrics, live metrics on sidecar or long-term metrics on object storage. So that's a good thing about this Thanos querier. Another good thing it does for us is about it call it deduplication. It's so because we have 3 instances of Prometheus here. If we want to add these 3 Prometheus to something like Grafana, when we query something, because they have the same config, these 3 Prometheus, they have the same config, they have the same endpoints to scrape. If we want to get one query, it returns 3 results for us. But when we connected that to the querier based on the replica label, it will understand, okay, this is a query, this is a metric, it does have the same labels, and the only thing is different is the replica name. So we'll let it know if everything is the same, just replica is not, is different, just combine the result for us. And that's a good thing it does for us. We don't need to worry about the duplications. And if by any reasons something goes down for one of these Prometheus servers, let's say we have a Kubernetes upgrade, and it will start to upgrade the node one by one, restart them. So in that period, all these 3 Prometheus servers might be down maybe for a few seconds, maybe for 1 minute, and that means we will lose some data. So who is going to fill in this gap for us? And that's going to be another cool thing that Thanos querier does for us. So if each of these Prometheus server might have some gap, I can say few seconds, maybe it's going to be few minutes in case of an outage. So Thanos query will fill in that gap for us and return the correct result. Otherwise, if it doesn't do that, then for sure we won't have accurate statistics when we want to visualize something. So that's a really good thing. It takes care of this deduplication. And also, the Thanos query is totally stateless, so it does not store anything inside itself. So it means very easily we are able to scale it up or scale it down based on the request it comes through this component. So that's a good thing. We don't need to worry about to scale it alone. That's already there. And the next component is compactor. As you see, it's connected again to the object storage. So
as you see in the name, this is the functionality is already present in Prometheus server, but in Prometheus, it's trying to get the block from local storage, compact that, compress that, and upload it again on the local storage. But when we are talking about object storage, then for sure we need to have the same solution for that. We need to get the blocks, compress that, and upload it again. So that's what Compactor is doing for us, to get the blocks from object storage, compress that, again upload it there. Another good thing it does for us is about the downsampling, which I mentioned that a few minutes earlier. So downsampling means the same example I used. So when we query something for 6 months, if we scrape the endpoint for 15 seconds, it's going to be 1 million sample. And that's too much if you want to just visualize that in Grafana. So downsampling, whenever it gets the block from object storage, in order to compress that, which we can say it raw block, it will create 2 more blocks for us. Blocks in 5 minutes and blocks in 1 hour. So that means instead of have data point for each 15 seconds, when you query something, for example, for 6 months, it will give you the data point for 1 hour. And it costs to speed up the query response for us very significantly. And that's a really good thing about the compactor. And if we decide to keep the metrics not unlimited, that's the only component which does have access, delete access actually, to block the older blocks for us. So if you say, let's say, we just want to keep the metrics for 6 months, and we can just give it the number of days we want to keep, give it to this compactor, and the compactor will delete all those older blocks from object storage. So let's go for the next one. Yeah, it's Thanos ruler. Yeah, you know, this is the functionality. It's already working fine on Prometheus, but we do use that here, a lot, because we have two things in Thanos ruler. It's alerting rules. All the rules we have for our alerting for infrastructure, of course. And the second thing is recording rule. And recording rule is something we use it a lot. It's some pre-computed query. I can show you an example in the next slide. You can see this as a recording rule. So this is a query, just one example, we use it a lot. It's a sum over rates for this specific metric, and then dive into another calculation. Instead of each time running this query, we just need to add it to the recording rule to calculate that for us and give us a new metric. So then we will use only this metric for the next use cases we have. So that's a really good thing, because what it does, when we have a bunch of recording rules, it will upload those recording rules on object storage again for us. So then we do have access to those metrics on object storage. And in some cases, here at Katowice, we don't use Thanos sidecar to upload all the metrics here, because what you get here, it's going to be all the metrics you have. Maybe not necessarily you need to keep all of them in a long-term storage. For example, maybe something like CPU usage, or maybe something like this kind of things. You don't need to store that in an object storage for 1 year. So, but here in the Thanos ruler, you could have some recording rules for those specific rules that you usually use them, and just store those on object storage. Then you will have a much efficient object storage as well. So this is the structure for all the Kubernetes cluster we have. All these components are present on the Kubernetes cluster we have. And if I want to show you the high level, how it looked like, so it's something like this. So you can see these are the clusters we have at the bottom. And then we have a global monitoring cluster. As you see, we only have one Grafana and also one alert manager. And this is another component from Thanos Global Query Frontend. You can see it as a frontend, that the backend of this component is all this Thanos query. Because as I said earlier, it does expose a read-only API for us. And via this component, we do have access to all the metrics which are available on object storage here, or those metrics, live metrics, which are available on Prometheus itself. So this component is connected to all this Thanos courier, and then we can query all the long-term metrics we have. What happened for that monitor? Yeah. Okay, so yeah, that's about the Thanos courier, and also we have one more Thanos global ruler. We keep all those it is specifically for alerting rules, those kind of alerting rules which we need to have it in a high level to calculating some of the SLO SLI we have. So that's where we need to have another global ruler to just take care of the alerting rule. We need to calculate some stuff in a high level. And one thing which you might you might be wondering why we have one object storage for each cluster. That was actually a trade-off, because it is possible to only have one object storage and let all these clusters to write there instead of have one single object for each cluster. So the reason we did it in this setup, it is more complex, but we wanted to keep our clusters, the metric clusters in each cluster, isolated from others. So if one day we decide to have a Kubernetes cluster in Asia, we didn't want to have all the metrics from Asia cluster alongside with the Amsterdam or Europe cluster. That's why we decided to differentiate this from each other. And another thing, if one day we decide to shut down a cluster, we can just shut down the entire cluster with object storage, and we don't want to care about those available metrics on the object storage. So yeah, that's it. Yeah. If you have a question, please let me know. Yeah. Questions? Yeah?
Yeah, sure.
Yeah.
So how many data points per second are we talking about here, and how quick can you query this using this? If you query a day or a month or 6 months, how long does that fast?
That's a good question, because as I said, the data point, we scrape all the metrics in each 15 seconds. So that's the raw. Yeah, that's weird. So the default data point is 15 seconds. But the thing is, if you want to just query this raw data point for 6 months, it takes a lot of time and it takes a lot of memory to get the result. So that's why the Thanos compactor, it gives us this capability to use downsampling. And in downsampling, so if you get those data points in 1 hour, for sure it needs less resources, because when we're talking about this data point for 6 months, it first needs to get a block, decompress the block, and then return the result for us. And that takes time. So especially if it's in 15-second data point. But if in the downsampling, if we're talking about 6 months, if we use the 1 hour, and if we zoom in for a specific period, then it's going to use the raw data point for us. Yeah.
So your queries always run in like a second or something?
No, it's not always second. We wish that, but yeah, one of the challenge actually we have here, the Thanos query, as I show you, is a stateless. It's going up, the number of pods going down. Sometimes when we ask, for example, for, 3 months, 4 months, when the query is very complex, it's not only one metric, it's a one metric, in a second. But when the query is really complex, sometimes it happens, it wants to scale up, but it doesn't have time. So immediately it needs, for example, 4 GB RAM. So it doesn't have that time to scale itself up. So what will happen? We just get a kill. The pod crash and return again. Then in the next try, it might work. So that's the thing. But the interesting point is, if the query is not complex enough, so it's worked fine. But if you want to have some kind of query, because in some cases we have a combination of 6 different
affects retrieving the objects? Or
Yeah.
I can try that. I think trying to apply different lifecycle policies in order to save on storage doesn't make much sense because you don't have control over the query. As long as you don't have control over the query, for example, you don't have restrictions for your users who are engineers to query those metrics, you can just go far from because retrieval from different storage classes goes more and more expensive, lesser and lesser storage costs are. So if you really want to leverage lifecycle rules and storage classes, it would allow you to save all storage. You have to restrict your use. Otherwise, you know, they will keep querying and querying and querying and querying. Imagine just one tab in your panel containing a query, reading query, and you don't have control over how many times you will be downloading an object containing metrics, which costs you infinitely more than a standard storage, which costs you almost nothing in terms of retrieval. So you need to be careful. It's doable, but I think for the purpose of gathering, it doesn't really make much sense. We don't have kind of the requirements to store this data for a long period, and you know, if we don't have these requirements, we don't need to build a complex system controlling those cases when things might happen that will cause you loss.
So we are like removing historical data.
Yeah, I think the kind of the standard procedure are lifecycle rules which could remove the data, but storage classes wouldn't make much sense.
Thanks a lot.
Hey. It's better we take a break now
Yeah.
because we need to clearly.
It's one by one that goes down.
Your pods are down too. So thank you. So short break, 10 minutes, and then we start with cool.
I will reach out to you, even if not in October. This was really nice. I got through I
Have you met Justin from Katowice?
Hi.
From the team.
Nice. Thank you for coming.
My pleasure. Hope to see you in the other events. Fortunately.
I hope we can get you.
And let's not luck with that.
Is there any way to pull the power?
We can definitely turn it off.
Calabaga ahora. Want some more? Hey, is this for you? Want some pizza?
Yeah.
Alessandro.
Italia. He was born in Poland. I lived in Italy very short. It was pretty long.
Okay. You like it?
Standard. It's still number one. It's still